If you have a mission-critical application, you don't deploy it as a monolith anymore. There's a reason Kubernetes is so popular. So why are you still using a monolithic database? Yugabyte DB is a distributed SQL database that you want for your global applications. It's 100% open source and designed to be resilient and horizontally scalable out of the box. It's PostgreSQL compatible, so you can start using it right away without learning a whole new query language. And you can distribute it wherever your application takes you, across availability zones, regions, and even cloud vendors. Go to yugabyte.com, that's yugabyte.com, and try the free beta of Yugabyte Cloud. It's a fully hosted and managed Yugabyte DB as a service, giving you a distributed SQL database for global applications with no operational overhead. It's effortless distributed SQL for global apps. Hi, I'm Scott Hansel, and this is another episode of Hansel Minutes. Today I'm talking with Andrew Sampson, the CEO at Rainway. How are you, sir?
I'm great. How are you?
I'm living the dream. I get to talk to cool people every day. And one of the fun things that I get to do, of course, is open 43 tabs and look at all the different people and what they've done. And I love looking at people's LinkedIns, especially when they have one that is like complete. And when I look at yours, it feels like you've had a vision for something and you've been pushing and pushing and pushing until technology and opportunity and ability all kind of coalesced. And now it's like happened. What does Rainway do?
Rainway basically allows you to decouple software from hardware constraints and build new types of experiences. And so those could be things like cloud gaming or, augmenting the way that scientists go about streaming particle accelerator visualizations into zero trust environments. All this works by providing GPU edge infrastructure across the continental US that you can then load any sort of native application onto, and then you can stream it from our edge into a web browser.
Okay. So let's parse that apart because there's a lot of words there. There's understanding of the edge. There's GPU versus CPU. Like, are you running your own cloud? There's other people's clouds. You're enabling other people's clouds. Let's parse that apart.
We're actually building our own cloud. We go and rack our own GPU servers inside of co-locations. Mm-hmm. And we do this, one, because of performance, but also it's cheaper. We get to give you a lower price as you're using our service than you would get from something like AWS, which we all know marks things up pretty egregiously.
Yeah, it's funny to me as someone who's been experiencing the rise of the cloud, and I can remember like the day it was invented and when it became the difference between other people's computers and the cloud. A lot of people have never seen the cloud. They've never experienced it. For them, the cloud is a slider bar or a checkbox. But for people like you, these are real machines that you've seen and visited because you own them.
Yeah. I've literally cut my hands putting some of them inside of the rack. So they are very tangible to us.
What was the early vision for Rainway when you started? You had a plan and it's pivoted a little bit, but let's talk about the original plan.
Yeah, we originally wanted to make a universal game launcher. I'm a big gamer, and I built it for myself at first. I was sitting in my living room and I went, wow, I really don't want to have to get up and go over to like my PC to play this game right now. And so we took this technology that I had invented for my previous startup, which was this remote administration enterprise company. And I took this web-based screen share protocol, and I spent basically all of 2017 with my co-founder optimizing it for real-time, low-latency streaming of video games. And then we started making this really comprehensive all-in-one game launcher that imported all your games from Steam and Epic and what have you. And you could play your games anywhere at any time. And it was really fun. The product's still alive today for people that do want to check it out. But that's where we started.
Now, there was a belief for a while there as web technology and open web technologies were kind of coalescing and GPUs were becoming more and more powerful that we thought that maybe people would compile their AAA games. You'd take Call of Duty and you'd compile it into WebAssembly and stick it in the browser or asm.js and things like that. And that kind of seems to have fallen by the wayside. You don't see a lot of that right now. It seems like there is a balance between what happens on the client, my machine, and what happens on the server, your machine.
Yeah, WASM is like still an incredible technology. I mean, of course, we even utilize it some ourselves inside of our SDK. But yeah, I mean, it doesn't solve one. You get worse performance if you compile like a AAA video game, right? It's a sandbox environment. It doesn't have quite access to the low level hardware that you need for something like Call of Duty to run at 60 FPS. And that puts a lot of limitations on the games itself. And so developers just don't even see it as a viable sort of target platform for compiling their applications. The second thing there that a lot of people just doesn't even click clip for them is DRM. WebAssembly is not something that you can protect very easily. You can take the WASM files and just run them anywhere, right? Mm-hmm. So you'd have to go through a comprehensive, like a lot of work to get it running in a browser, and also making sure people could pay $59.99 to actually play it.
Mm-hmm. Back in the day, I used to install plugins, which I call virtual machines within a virtual machine within the larger operating system that may or may not be a virtual machine. And suddenly you're in this Inception-like world. Like Flash itself existed as a vote of no confidence against the open web. It was like, well, if you're not going to do it, then I'm going to make a square that lives inside your square, that'll do it myself. And Java was another. The Java applets were that. But when all those external plugins and native extensions disappeared, I guess we're screwed, I thought to myself. But at Rainway, in one of your famous blog posts, you said, no, that's not an intractable problem. That's Tuesday.
It is pretty much an average Tuesday for us. We have to spend a lot of time thinking about how to get native apps running inside of the browser as if they were native applications built for the web to begin with. And so, I like to say, like, the streaming is only one component, but like we do little things, right? Like, so you work on the .NET team, you're familiar with WinForms. One of the things that we've done is we've actually written low-level hooks for the operating system that will detect when a WinForm pops up, any sort of widget like form or panel, and then we can actually send those events over to the web and display a native like web modal. So that way, like when you click File Open, the File Explorer opens. It doesn't take you out of the experience. It doesn't feel like you're streaming an app anymore, because you get a nice little web-based file picker that's like local on your machine and it's not streaming. And just those little things make the experience all that much better.
That's interesting. This is a stretched analogy, but it makes me think about technologies like Wine that allow Windows executables to run on Linux, where the Windows executable is living in the matrix. It's being actively lied to, and it says, I'm going to open a common Windows file dialog box. And Wine's like, sure, you will let you think that. You believe that. And then it'll go and open the Linux common file dialog box.
That's essentially what we do. Yeah, we make Windows applications think they're really running on Windows, but in reality, they're going through, the Rainway OS layer. Then they go to Windows if they need to.
Yeah, right. So Elon Musk thinks that we're all living in a simulation, and we don't know because the simulation is so accurate that how could we know? The applications, the games that are running within the context of a cloud like this, the illusion is so complete that they didn't need to be recompiled. They just are being lied to very, very effectively.
Yes. And that is the key to making this experience really good for end users.
Okay. So when I run Netflix, or the app that I'm currently upset with right now, which is HBO Max, and I feel like, I just seeked. I grabbed the little dot and I seeked over here, and now I'm waiting, and now there's buffering. And I'm thinking to myself, this is not optimal. Even now in 2021, there's still apps that don't do that kind of stuff right. Milliseconds matter and seconds are totally unacceptable. I honestly don't know how they're painting to the screen. Like, I know that there's a canvas, and I know that there's WebGL, and I know that there's many ways for a browser to get a pixel onto the screen. Those are limitations, though, you have to work within.
Yeah, we have to spend a lot of time thinking about how to optimize in other vendors' environments. And so whether we're building an application for tvOS or we're building it for the browser, we have to take our technology, which is designed for low latency decoding and presentation of video frames, and make that work in an environment regardless of the limitations that are there. So like in the browser, we bypass a lot of like the standard APIs that a lot of people are using. We're like rolling our own decoder in some places, and we're actually doing some really low level optimizations on the canvas to get those video frames presented to you. But all of this is in the pursuit of being able to stream something from a remote server into your browser in under 20 milliseconds so that you can have full interactive experiences.
I was trying to explain to my non-technical partner how this stuff works, and I was using the Netflix analogy, and it's like, imagine Netflix, except the movie yet hasn't been filmed. And what comes next, the frame that comes next, is totally dependent on what I'm doing. And we're going to, in real time, make this movie and then also send it down and also make it look good.
It's a really good analogy.
I'm glad. That's my superpower. And that's why I've been doing a podcast for so many years, is that all I do is really stretched analogies and then hope that they land well. So that makes me happy.
Yeah. It's definitely like you're painting on the fly. It's like being at the edge and constantly having to draw the next picture yourself.
So if I'm playing a game, let's say that I'm, playing Metro Exodus, which is a game that'll really stretch the limits of anything. My son thinks that there's just an Xbox just sitting in a room somewhere. Maybe it's down the street, maybe it's in another state, and we just, where just is in air quotes, take that picture and send it over to here, and that's the simplistic view. Is that what's happening?
Yeah. I mean, like for some people, it's like an unlimited, an HDMI cord with an unlimited length, right? It should just work and it should have that convenience. But really what's happening under the hood is we're taking that frame off the front buffer, of the Xbox or the PC. Then we're doing like post-processing magic on it. We're encoding it into like an H.264 frame or H.265 or AV1, whatever, like, the codec we negotiated ahead of time was. And then we're putting it onto the network, and then you have multiple options, right? If you're streaming into the browser, you're going to go with WebRTC. If you're streaming into a native environment, for us, we have our own proprietary protocol called GUP, which is just basically good user datagram protocol. And so we stream over that, and then we have to do magic to account for the fact that while in a perfect world in a lab, networks are incredibly stable. They never have any problems. In reality, you can drop packets. You can, end up on routes where you have lots of hops and you have an unoptimal sort of like direct connection to the other peer. And now we have to do things like rebuild packets dynamically. This is actually one of our cool features where if we lose up to 30% of a packet, we can just rebuild it on the client without retransmitting it, which, you get like 1 to 2 milliseconds of overhead on that, but that's better than sending an entire video frame back again to maintain that sort of consistency. And then, of course, now you have to decode it. And like that, talking to low level like system hardware and whispering to it in just the right way so that it presents your frame. And then it does that 60 times a second.
Yeah. That idea of rebuilding a corrupted frame or dropped packets, it makes me think about like RAID, where it's like, imagine that your hard drive just errors out 30 times, 30% of the time, and you're just going to pretend that didn't happen and just rebuild everything and not mention it to anyone.
We just don't mention it. And then, if we can't rebuild it, you're going to get a little bit of a hiccup as we restart the stream.
Right. Exactly. Which is actually what's happening right now, because with the video that I'm seeing right now on this side, it's pretty mediocre in the tool that we're using right now, but I know that at the end of it, we're going to be able to rebuild this and it's going to look amazing on YouTube.
Right.
Yeah. So I use that term just, and I've actually done TikToks and blog posts about how it is a way for engineers to understand that a thing that seems magical is possible. But it's also a very minimizing word because it minimizes a lot of the really amazing engineering work that happens. So I'm going to ask a just question, which is something that I actively publicly say don't do. Okay. Why didn't you just use WebRTC and FFmpeg and GStreamer and WebSockets? That's all you really had to do, right? Why isn't that just the right answer?
So the answer to that question is the same reason a lot of our customers didn't. They all tried initially. And so did, even when we were imagining this, we asked ourselves, do we have to reinvent the wheel? Do we have to create our own thing? What open source standards and technologies exist for us to leverage? And when we applied them and we were able to build these proof of concepts, what we saw was they just didn't hold up under pressure, right? They didn't there was no sort of accounting for, inside of like, WebSockets, what happens when packets and frames start to drop and you end up retransmitting them. That's TCP. And so now you end up with these huge buffers. There were all these different issues that were in these open source standards that we finally just went, okay, well, looks like we actually do need to create something ourselves here. And then we start to realize this is really important, because we don't want to be reliant on other vendors. We don't want to be reliant on an open standard when it comes to something that's brand new. We have to sort of like break out of that cage and go and build our new standard for ourselves. And it's like shown that was the right path, because we've created something that has incredible performance and is able to hold up even under the worst network conditions and provide, these AAA experiences that everyone's looking for. And if we just use WebRTC or we just use WebSockets or we just use FFmpeg, we would be bound to the limitations of that software. And it's very hard to get like any sort of contributions, especially to, very standardized things actually implement it, especially if they're breaking changes.
Mm-hmm. So you've got this stack, right? The stack that we have built up from TCP up or IP up, and you have to go and say, well, is this the level? No, it's not that. Is this the level? No, it's not that. At some point, you're just sockets, right? But what is the metal in a world where the metal is Safari or the metal is the Tesla Chromium browser? Like that's the new assembly language at that level. And you cannot go below that.
Yeah, I would say like we see browsers as virtual machines, right? They are this window to thousands of applications that can run in a secure environment, all from inside of like one application, which is your browser. So they're incredibly like complex pieces of software, and we just have to engineer around either, do tricky things to trick the browser. And we do that quite a bit to trick the browser into doing something it wasn't actually designed to do. So like maybe we're putting some magic numbers at the front of a frame buffer that causes the browser to seek ahead and to code things faster than it normally would, or maybe we're like doing like, basically low level optimizations akin to sort of like Doom's WTF for like speed hack for floating point numbers. Also that we can like get the browsers to perform. But I should also say on the network side, even at that TCP IP layer, we've actually gone a step like ahead. A lot of like network protocols, even WebRTC, are all really based on the CPU. Our network protocol actually runs entirely on the GPU. That way, when we're encoding video frames, we're able to transmit them onto the network adapter without ever touching the CPU. It's actually a very like complex engineering suite, but it allows us to bypass a lot of unnecessary copies and also some of the kernel and just go straight to the network adapter and transmit.
How do you even start to debug something like this? I mean, this is very much a thing where you're doing stuff, like you said, 60 frames a second, 30 frames a second. You're doing things where 10 milliseconds matters. Somewhere inside of Rainway, I suspect at your company, there is a whiteboard with a pie chart that shows in milliseconds where the work's happening. There's a flame graph somewhere. And you're like, 3 milliseconds here. And then someone's going to work on that problem for months. Does that exist somewhere?
Yeah, so I would say in the early days it did, and that was both on the encoding and decoding side. And so the way that we think about designing our technology is that if the encoding and the decoding are as fast as they can possibly be, then we have room for error on the network because that is the most variable thing. We can optimize and get our encoding and decoding working for like a set of like different like GPUs and different APUs that exist out there. And we can get that working fast, right? Like we were able to encode 1080p at 60 FPS in as low as 2 milliseconds now and decode it on like an iPhone 12 in like 1 to 2 milliseconds as well. So like that's super, super fast.
Oh, wow. I had no idea.
And that gives us a lot of room to be able to like have, okay, well, this person's network is like a little like crappy and it's like hiccuping every now and again. Now our rate controller can kick in and it can start making some guesses and optimizations to the actual network side of things. And like that additional overhead doesn't impact you as much because we were really fast on these other two steps.
Mm-hmm. Are you under increasing pressure to ship code faster than ever before? Then it's time to work smarter with Raygun's modern approach to error and performance monitoring. Raygun gives you instant visibility into the health of your software. And what makes it so unique is that it not only tells you when something's gone wrong, it shows you exactly where it's gone wrong and how to fix it, right down to the line of code. Made by developers for developers, Raygun has built a suite of monitoring tools that are used and loved by thousands of software teams every day. You can monitor every corner of your tech stack with widespread language support and native integrations with GitHub, Jira, Slack, Bitbucket, Octopus Deploy, and more for even greater visibility. Visit raygun.com to resolve issues faster and to deliver flawless digital experiences for your users. That's raygun.com to get started on your free 14-day trial with plans starting from as little as $4 a month. raygun.com. Recently, I have an iPhone 12. I'm holding it up for those who may be watching this on YouTube. But if you're listening, I've got an iPhone 12 Pro Max. And, I had always thought that Microsoft would come up with an app or something that would let us play Xbox games. And I read some articles on The Verge that wasn't happening for limitations. And there's arguments. And there's all kind of lawsuits with Epic Games. And the whole idea of like, are app stores within app stores going to be a thing? Now, for disclosure reasons, I do work at Microsoft, but I don't have any inside dope. So I'm just talking about what I have personally read on The Verge, that there was talk of some kind of a ability to do that. And then Microsoft pivoted. And now I have an Xbox Game Pass Ultimate account, and I have an icon on my iPhone that says cloud gaming that is just a shortcut to Safari. And when I click it, I see a Safari pop up and I log into my Game Pass Ultimate beta account here. And then I've got a Backbone, which is this great, lovely little stretchy controller. And I'm freaking looking at Xbox games on my phone. That's nuts. But when I heard about that there was a pivot occurring, it showed up in Safari very quickly, surprisingly quickly. I'm like, wow, there must be some smart people. But there's a partnership going on here, isn't there?
Yeah, that would be us. We set out. Microsoft reached out. It just happened to be the right series of events that occurred, and they reached out to figure out how we could help them get onto iOS and also browsers. And browsers for us at the time we were still a consumer gaming company, but we knew the browser was really important early on, so we spent a lot of time optimizing there and getting that experience good. And the right folks saw it at Microsoft, and they wanted to see if we'd be able to help them bypass some of those Apple limitations and accelerate their go-to-market. And I'm proud. I'm really proud to say we did. I think it was just a couple of months it took to get everything like turned around and like stood up, and everyone got the Xbox beta.
And that's that Rainway SDK that powers not just games, but other opportunities. Anything where there's a GPU accelerated, something's happening on a frame buffer somewhere, and you want to bring that closer to the edge. That's where the Rainway SDK gets involved. And of course, you can reach out at rainway.com to like get involved. If you are listening and you're thinking that maybe we have a problem that could be solved by this SDK.
Yeah.
Yeah. So this idea of ultra low latency, though, you're fighting with the Safari or the Tesla browser or any browser that could potentially change stuff. Is there some fundamental building block that you're using that they being the powers that be, can't take away? Like if they said, we don't like this, we don't like Rainway, we don't like what xCloud's doing, we're going to turn that off. But you can't, because you're using JavaScript or you're using WebGL or you're using what to paint to the screen. What can they not take away because it's part of the open web?
Yeah, we build around standards as much as possible. And of course, like where we think a standard isn't good enough, and that's happened quite a few times, we either fork the browser and make the contribution and improve it ourselves. We actually have a few commits to Chromium just like to make certain things better, or we just don't use the standard and we go a completely opposite direction. Like one example of this is like our proprietary network protocol has browser compatibility, which means that we're able to stream GUDP into your browser with our WebRTC shim. And one of the ways that we're able to do that and also get better video is like a lot of folks will use WebRTC video to do screen sharing in the browser via WebRTC, not knowing that has a minimum latency of like 150 milliseconds, and there's like a bunch of different stuff that makes it not really good for interactivity. We actually use data channels, the low-level data channels, and then we're able to then handle the coding ourselves and handle the post-processing ourselves, and really just like remove as much control from the browser as possible, and just treat it as a very dumb pipe that we can send data across and then do all our magic ourselves.
Interesting. All within the virtual machine, the platform that you've decided to target. So you're thinking about the browser, like you said, as a compute module that just happens to be on the edge and trying to get as much of it out of the way as possible.
Correct. Yeah. And we really don't like having to be reliant on vendors, which is why we minimize the amount of like official APIs from the vendors as we can.
And you're not doing anything tricky. You're not saying like, this is a thing that we can't really count on. It might go away. So cross our fingers, it won't be a problem.
There was some of that in the early days, but like that was back when browsers were still like figuring out if they wanted to support these kind of use cases. Now they've either been standardized or we just added its official support in, and we removed our hacks.
Seriously?
Yeah.
Interesting.
Yeah, it was really nice. We actually saw a new browser API get added to Chrome, and one of the like references for why they added it was us. Like they were like, we saw Rainway doing this hacky thing, so we added an official API so that they didn't need to.
So that's interesting. So this idea of the technology that's going to power this, like you said, it could be open standards, but when these lower level APIs that they see you using, they're like, yeah, we want to enable this. We don't want that to accidentally break or become an issue. So we're going to
and we're actually seeing the web evolve quite like, it helps that like Google has Stadia and that they're getting involved in this process, but we are seeing like web developers and standard writers actually paying attention to some of the non-standard use cases of the browser, people that are doing brand new, really cool things like us. And they're actually going, yeah, let's implement an API that helps make this a little easier. That's really cool to see.
Yeah. I have seen recently, because I also have a Switch and I'm a big Switch gamer, I've seen apps, and I bought one, and I said I didn't realize that I wasn't buying an app that was on a card. Does Rainway have involvement in Nintendo Switch? Because I bought an app for $30 and it's a streaming entirely experience, and I didn't know that when I bought it.
I wish. Unfortunately, we don't really have a hand in that. In the early days of Rainway, we did try to get on the Switch. We actually built a proof of concept. So fun like tidbit. I don't think I've ever actually shared this before. I bought a Nintendo Switch from Best Buy. This is like originally the first run of them. And then I rooted it so that I was able to like get access. And then I basically started side loading our own custom app onto it.
Yeah.
And then like I was showing Rainway running on a Switch to show that it could work, even though the early Switches poor Wi-Fi adapter, and people just like lost their minds.
That's interesting that you do that. What's fun about that I think as a technologist is that it's organizational willpower, it's business, it's marketing that allows or disallows things. Like we mentioned, PlayStation crossplay or crossplay in general. And I recently had the CTO of Roblox on and talked about things like a tunnel in the metaverse where someone from Roblox could walk into, Fortnite or back, and they could share a concert between multiple walled gardens. All of those technologies, and like your example of making something work on the Switch, it's a computer. It's not technology that's keeping us from doing these cool things. It's simply organizational willpower.
Also, I should say, like, part of the reason we're building our own infrastructure is because we want to be a backbone provider for the metaverse, right? That tunnel you're talking about. Well, you don't want to, if someone doesn't have both Fortnite and Roblox installed, they shouldn't be kept out of the tunnel. They should still be able to access it. If you can just stream either Fortnite or Roblox when you go through that tunnel to the end user inside of their own game, so that they're able to still experience this new 3D environment without it actually being local on their PC. Well, now you're allowing new groups of people to interact without having to install another 60 gigabyte game or having to be able to run that game. And so, like, that's one of the things that when we're building this infrastructure, we're being very cognizant about, because being part of the metaverse, that would be our ideal goal.
Yeah. One of the things that I think is underlying that's fundamental, that doesn't get talked about enough, is when we talk about inclusion in computing and in gaming, it is meaning explicitly not excluding people. And to exclude someone because their computer is too weak and they don't have the new iPhone 12 is meaning that they're not going to have that involvement. Now, the way that the Roblox folks are currently solving that is with a game engine, a client that's really smart, that it can scale down. But you're having a no compromises perspective and you're not going to worry about the compute. There's enough compute on any phone to enable AAA gaming today.
Yeah. And the way that we see it is like, we just want to save game developers and also all developers time to not have to make those smart engines. Like, allow your engine to be, as beautiful and breathtaking as you want it to be, because you have the confidence that even if someone's using on an iPhone, they basically still have a GTX 3090 plugged into it, an RTX 3090 plugged into it, because our edge infrastructure is actually doing all the heavy lifting.
That brings to mind, speculating here, the future. It's not client, it's not server. It's an acknowledgement that there is power in this machine. Even a low-end Android is a hardware accelerated quad processor machine, and maybe the responsibilities get split. There are smarts in the Rainway front end that are enabling
hybrid approach. Yeah, we think about this a lot. Not everything has to be streamed. UI elements are a great example of this. They change, very rarely. They're static most of the time. One of the example applications we provide to our partners is a WinForm application where the entire WinForm app is native, but then there's a panel where everything in that panel is streamed from our edge. And so you can display this complex 3D scene, but still have all your UI elements native from the local computer. And that sort of hybrid approach, we foresee being very popular once we open up our cloud to the public.
Mm-hmm. That's really cool. And then, as we get towards the end of our conversation, though, I do want to acknowledge the work that you've done over the last, several years. There's a very powerful Medium post that you've written where you want to let other people know that the American dream and supporting the next generation of Black founders is really something that is you're passionate about, and that no matter how modest someone's come up is, that really cool things can happen if you have the right opportunities and the right technology and education available to you. So your story is really impressive, and I'm going to include links to that in the show notes.
Yeah, thank you. It's been an incredible journey. And for me, a lot of this is about building cool tech, but mostly it's about making sure that people can walk in my footsteps and not have to go through a lot of the difficulties that I had to. Black founders have it hard already. And for me, finding success is about being able to give them a ladder so that they can just skip past some of the crap that I have to step to on a daily basis.
Yeah. It's cool because you're sending the ladder back down, but also acknowledging that people will be standing on your shoulders, and you are standing on both the technical and social shoulders of people who came before you, which I think is really cool.
Yeah.
Yeah. Well, thanks so much for chatting with me today, Andrew Sampson from Rainway.
Yeah,
it's
thank you
cool
for
work
having
that
me.
you're doing. And people can learn about all this stuff at rainway.com, learn about the SDK, certainly Google some of the great stories, and check out Andrew's Medium posts and follow him on Twitter. There's great work happening both on the Xbox side and supported by Rainway and the Azure Cloud. This has been another episode of Hansel Minutes, and we'll see you again next week.